by December 19th, we would have enough data. There would be a flood of data that would tell us what this object is, but let's wait and see.
Do you think NASA is open-minded, or do you think NASA's just decided it's a comet and we're going with that?
Well, bureaucrats or unimaginative scientists want us to believe in the expected. But the rest of us know that the best is yet to come. Life is worth living if we allow for the unexpected to surprise us. And, science is a learning experience. All I'm suggesting is let's collect more data to figure it out for sure. Okay. Because we cannot be sure right now.
The countdown has begun. Only days are left until 3IATLAS, the interstellar comet that has captivated astronomers and sparked global curiosity, makes its closest approach to Earth. In just a matter of days, this mysterious object will come closer than it has ever been, providing scientists with an unprecedented opportunity to study its peculiar characteristics. Yet, as we prepare to observe 3IATLAS in greater detail, the more we learn, the more questions arise. Far from following the expected behavior of a typical comet, 3IATLAS continues to defy the laws of physics, leaving astronomers scrambling for answers. What secrets does it hold, and what will we discover as it inches closer to our planet? In just a few short weeks, the comet will come closer to Earth than it has ever been. In fact, it will be more than twice as close as when the Hubble Space Telescope captured its iconic image, one that has since become synonymous with the object. This proximity offers a unique opportunity for scientists to study 3IATLAS in greater detail than ever before. The Hubble, along with the James Webb Space Telescope and other ground-based observatories, will be able to capture images with a new level of clarity, allowing researchers to delve deeper into the comet's structure and behavior. But as scientists prepare to observe the comet more closely, they do so with a sense of unease, for 3IATLAS is not behaving like any comet we've studied before. Most comets, as they travel away from the Sun, become less active. As the comet moves farther from the Sun, the heating that drives outgassing from the nucleus diminishes, causing the comet's coma, the glowing cloud of gas and dust surrounding it, to fade. The tail, a characteristic feature of comets, begins to shrink and becomes less visible. This is the expected behavior of a comet as it moves through the solar system. However, 3IATLAS has not followed this pattern. Despite being farther from the Sun than it was when first observed in July, it remains surprisingly bright. Observations from amateur astronomers have revealed features on 3IATLAS that seem to suggest that the object is far more active than expected. While it should be fading into obscurity, the comet continues to display unexpected brightness and features, raising alarms about its true nature. What makes 3IATLAS truly extraordinary, however, is not just its unexpected brightness, but the peculiar structures surrounding it. One of the most baffling features observed is the anti-tail, a strange and highly unusual phenomenon where a comet's tail seems to point directly toward the Sun. This anti-tail, which extends millions of kilometers from the comet, is a feature never before seen in such magnitude. It has left astronomers scrambling for an explanation, as it defies the traditional understanding of how cometary tails behave. Usually, a comet's tail stretches away from the Sun, driven by solar wind and outgassing from the comet's surface. However, 3IATLAS appears to have a tail that points toward the Sun, a configuration that contradicts our understanding of cometary physics. At first glance, one might suspect that this could be an optical illusion caused by the spacecraft's position relative to the comet. Such illusions are not uncommon when observing comets from different angles. But the data indicates that this is not the case. The anti-tail of 3IATLAS is not merely an artifact of observation. It is a genuine feature of the comet, one that has been observed consistently in images captured by various telescopes. This raises a fundamental question. How can a comet have a tail that points in the opposite direction from what we would expect? To understand the significance of the anti-tail, one must first understand how cometary tails form. As a comet nears the sun, the heat causes the icy nucleus to sublime, releasing gas and dust. The solar wind, a stream of charged particles emitted by the sun, pushes this material away from the comet, forming a tail that stretches out in the direction opposite the sun. However, 3IATLAS seems to have an anti-tail that points directly at the sun, something that should be impossible under normal circumstances. If this anti-tail is not an optical illusion, then something very unusual must be happening to 3IATLAS. What makes this discovery even more perplexing is the size of the anti-tail. The structure stretches at least 1 million kilometers into space, a length that is difficult to comprehend. To put it into perspective, if an object were traveling at 400 meters per second, which is faster than the speed of a bullet, it would take an entire month to cover a distance of 1 million kilometers. Yet, 3IATLAS's anti-tail is not being erased by the intense solar wind that should be sweeping through that region of space. The solar wind at the location of 3IATLAS is moving at approximately 400 kilometers per second, which is 1,000 times faster than the thermal speed of gas naturally released from a comet. For the anti-tail to persist against such a powerful force, the material must be far denser than what we would expect from a typical comet. Some scientists have suggested that the density of the material making up the anti-tail could be at least 1 million times greater than the density of the solar wind itself. But if this is the case, the amount of mass being expelled from 3IATLAS is staggering, perhaps as much as 200 metric tons per second. Even more troubling is the fact that 3IATLAS seems to be losing an enormous amount of mass. Over the months of October and November, the object is believed to have lost several billion tons of mass, a loss that represents 10% of the estimated mass of the comet. If this were a natural comet, this level of mass loss should have shattered the object, yet 3IATLAS remains intact, its structure seemingly unscathed. This raises an even more baffling question. If 3IATLAS is a comet, how is it able to survive such massive mass loss without disintegrating? The answer may lie in a phenomenon known as non-gravitational acceleration. In most comets, non-gravitational acceleration occurs when the uneven outgassing of gas and dust causes the object to experience a slight push in a direction other than the one dictated by gravity alone. This push alters the trajectory of the comet, but typically only in very small amounts. However, 3IATLAS has shown signs of significant non-gravitational acceleration far beyond what would be expected for a natural comet. The object's trajectory has changed in a way that suggests it is being propelled by something other than the typical outgassing seen in comets. This level of acceleration would require more than 10% of the comet's mass to be expelled as gas and dust. However, even this calculation doesn't explain the behavior observed in 3IATLAS, further raising doubts about its natural origins. Some researchers have speculated that the acceleration could be due to artificial propulsion systems, such as chemical thrusters or ion engines. These systems can achieve much higher exhaust speeds than natural cometary outgassing, potentially explaining the observed acceleration. However, this theory raises another set of questions. If 3IATLAS is not a natural comet, then what is it? Is it a piece of technology from another civilization, or is it something entirely different that we have yet to understand? Adding to the mystery surrounding 3IATLAS is the fact that the comet is headed toward Jupiter, and its trajectory brings it dangerously close to a critical region known as the Hill radius. This is the point in space where the gravitational influence of a planet, in this case Jupiter, overpowers the sun's pull, making it an area of particular interest for astronomers. The Hill radius is often referred to as the solar system parking lot, a prime location for placing spacecraft or probes for extended missions due to its stable environment. The fact that 3IATLAS is on a path that will bring it near this region has led to some to speculate that the object's movement might not be entirely random, suggesting it could be headed toward a destination with purpose. possibly even designed for future exploration. However, the plot thickens when we consider recent adjustments made by NASA to the data regarding 3I/ATLAS's trajectory. Initially, it seemed the comet would pass directly within Jupiter's Hill radius, a fascinating and potentially unprecedented event. But subsequent revisions to the non-gravitational acceleration data, along with altered calculations, now suggest that 3I/ATLAS might miss the Hill radius entirely, brushing just outside its boundary. This sudden change in the predicted trajectory has raised suspicions among some observers, leading to theories that NASA might be downplaying the significance of 3I/ATLAS's path. With no clear explanation provided for the change in calculations, these adjustments only add fuel to the growing intrigue surrounding the object and its mysterious journey through the solar system. As the mystery of 3I/ATLAS deepens, the question remains: what exactly is this object? Is it a natural comet, or is it something far stranger? And as we continue to study it, we may uncover answers that challenge everything we know about the universe. Whatever the case may be, one thing is certain: 3I/ATLAS is no ordinary comet, and it has left an indelible mark on the study of our solar system.